Hi everyone, welcome to another video tutorial. So today we're going to talk about how sine and cosine functions play out in a right angle triangle, right? So I'm going to start off with the theory, and then after the theory I'm going to put in many examples and exercise questions. So if you guys already are familiar with the theory, you can skip, and I'll put the moment where I'm going to start with the exercises in the description below. So let's get started with a right angle triangle, right? I'm going to go ahead and draw a right angle triangle. Okay, and so this angle, we know it's 90 degrees, and we want to talk about this angle, right? So let's call him theta, right? So now let's see what it means to have the function of sine of theta, cosine of theta, and also tan of theta. Okay, we're going to talk about cotan later on, but it's very similar to tan, so you don't have to worry about that right now. Okay, so the first thing I'm going to do here is that I'm going to just go ahead and give letter names to each of these sides, right? I'm going to just name them ABC, right? So forget about SOHCAHTOA or any other, nonsensical whatever formulas that or keywords that, anyone has taught you before. So I'm going to go ahead and give you guys something very easy that will help you memorize the definitions of sine, cosine, tangent very fast. So the first thing is that we know for sine and cos, right? Obviously everything is a fraction. So these guys are divided by the largest side in the triangle, right? So the reason for that is because the largest side is the strongest one. So they're going to say, okay, I'm going to divide it by the strongest side. Okay, so now think about sine. Here for sine sounds like sight, right? So I want you guys to memorize that, right? Sine sounds like sight. So what is in our sight for the theta? The one in front of us, A. What else is left? So we already used C, we have A. For cosine, it's B. Okay, so whenever you guys draw any sort of triangles like this, right? Like that, or even, something like this, right? You want to talk about this angle, for example, here, right? So let's call it X, right? So we say sine of it is divided by the largest one. So let's call this, 40 centimeters, right? So divided by 40 centimeters, right? The largest one, because the largest one is always the strongest one, so it takes precedence in cosine and sine right here, okay? And then for sine is the guy that we can see right in front of us, right? So let's say if this one is 10 centimeters, or let's give it a more practical number, 30 centimeters, right? This one was 30 centimeters. Then you know that your sine is actually centimeters divided by centimeters cancels out, is actually 30 divided by 40. That's it. So the cosine of x still divided by the largest number. Now we already used the number that is in front of us. So what is left? The one that we can't see quite really well, right? So this one, for example, question mark. Okay? Alrighty. So for tan, that's pretty much it. I'm going to go ahead and erase these guys. We're going to go back and talk about the tan function, right? So tan is basically what we can see divided by what we can't quite see. That's it. So the thing that we can see obviously takes precedence because it's right in front of us, right? We can see it. So what we can see divided by what we cannot see. And cotan is the inverse of it. So the only thing that I want you guys to memorize is sine of theta. That's it. That's the only thing I want you guys to go ahead and memorize the definition for, right? So once you know sine of theta, or sine of x, or sine of whatever, is obviously divided by the largest side, right? And then on the numerator, I'm going to put what I can see. Okay, then what is the cos? Obviously divided by the largest side, because he's strong, right? We're going to put it right there in the middle, at the beginning. And then we already used A, so the only thing that's left is B. Okay? Tan is what I can see divided by what I cannot see. Okay, and the whole C site, whatever, sine site, this is the I would say quote unquote keyword that you guys can use and just kind of like, you know, keep it in mind. And then cotan is just the inverse of it, right? So we're gonna switch the position of sine and cos, right? We're gonna just flip the fraction. It's gonna give us cosine of x divided by sine of x. So do not worry about, right, not knowing right off the bat what's the definition of tan. Write sine, write cos, and then you'll get to tan. And trust me, after 10 times of doing it, you'll be much, much, much quicker, okay? So right here, I'm gonna go ahead and do some exercise problems, all right? So let's get started with a exercise question here. Okay, I'm gonna put in exercise number 1, all right? So I'm gonna go ahead and say, I have a right angle triangle here, okay? And so here is my 90 degrees, all right? And I'm gonna call this my x value, all right? So I'm gonna say, find the sine of x in the following, you know, diagram, right? So I'm gonna give this 3 centimeters, I'm gonna give this 4 centimeters, and obviously from the Pythagorean theorem, we know that this is gonna be 5 centimeters, okay? So we said that sine is what rhymes with site, kind of, right? So we're gonna write sine, okay? What we can see right in front of our eyes, 4 centimeters, divided by the big guy, the hypotenuse, right? The largest side in the triangle. So basically sine with sine cancels out. My answer is gonna give me 4 divided by 5. That's it. Okay, so now if they told us find cosine of x, okay? I'm gonna go ahead and write cosine of x is equal to, obviously I already used 4, so the only other side, other than the big guy that is left, is 3 centimeters, okay? So I'm gonna write it 3 centimeters divided by the big guy, 5 centimeters. Centimeter cancels out, gives us 3 over 5. Okay, that's it. If they tell us find tan of x, okay, I'm gonna say what I can see, site, what I cannot see, right? So tan of x is what I can see, 4 divided by 5 divided by 3 divided by 5. Okay, that just gives me 4 over 3. All right, find cotan of x. Cotan of x is basically the inverse of my tan. So instead of 4 over 3, I'm going to write 3 divided by 4. Make sense? Okay, good. So let's do another exercise problem. I'm going to write ahead, right, exercise 2. Okay, so we're going to have, again, another right angled triangle here. Okay, and I am going to say that we know that sine of x is equal to 0.5. Okay, so this is my x, this is my 90 degrees. Okay, so find the hypotenuse, find cosine of x, find tan of x, and then find cotan of x. All right, another given in this function is that, for example, here we've got 10 centimeters, okay, or even 10 with no units, just 10. Okay, all right, so we're gonna say that sine of x is given, right? That is the given value, is equal to 0.5, right? And is equal to what? Is equal to what I can see right in front of me, so 10 divided by the hypotenuse, the largest value in my sides, okay? So if 0.5 is 10 divided by hypotenuse, what does it give me? Hypotenuse, we're gonna do cross multiply. Hypotenuse is actually 10 divided by 0.5, and that gives me 20. That is the value of hypotenuse. Okay, so then the next one, find cos of x. Again, divided by hypotenuse, we already know it's 20, right? And cosine is the one that we can't quite see. We already used 10, so the only other side other than the hypotenuse that is left is this guy. Let's call him question mark. Okay, so it's question mark divided by 20. Now, think about it for a second. How are we going to find the question mark? One way we could use is the the Pythagorean theorem. Pythagorean theorem, right? So we're going to say that question mark to the 2 plus 10 to the 2 gives us 20 to the 2. Okay, so question mark to the 2 is, I'm going to take this guy on the other side. It's going to give us 400, that's 20 to the power of 2, minus 100. Gives us 300. So then question mark is 10 square root of 3. That's it. All right, 10 square root of 3. So this question mark here is going to give me 10 square root of 3, and then divided by 20 gives me square root of 3 divided by 2. And we already know that the cosine of the angle, wink wink, that the sine is 0.5, aka 30 degrees. This is one of the famous angles that we should know. The cosine is square root of 3 over 2, so that is the right answer. Okay, next off, I'm going to find the tan of x. Okay, so tan of x is what we can see, again, sine, sight, divided by what we cannot see, cosine, non-sight. Okay, so sine is 0.5, already given in the problem, divided by square root of 3 divided by 2. Okay, I'm going to do a quick calculation here. Gives us 1 divided by square root of 3. Usually, this is right, this is fine. Usually in mathematics, we don't want to have a non-rational denominator, right? So we do a process called rationalizing the denominator. Multiply both by square root of 3. Square root of 3 gives me square root of 3 divided by 3. So these two values are exactly the same, right? So I'm going to be talking more about rationalizing fractions. Rationalizing fractions in the future. But for now, either of these two would be the correct answer. Okay? So, cotan of x, just the inverse of that. Inverse of this, cotan of x. What's the inverse of that? Square root of 3 divided by 1. That's it. Finished. Okay? So let's do a third example. Okay? So let's do something like this. Okay? So we know that the 90-degree angle is here. Okay? And then we have x is equal to here, y is equal to here. Okay? So we're going to say this is 2, this is 1, and this is r. Obviously, hypotenuse is in front of 90 degrees. Okay, good. So now the question is, find the relationship between sine of one of them and cos of the other guy. Okay, so one angle is here, x, the other angle is here, y. So find the relationship between sine of x and cosine of y. Okay, so sine of x, let's write it. Okay, and we're going to write cos of x, just for practice, we're going to write sine of y, and then we're going to write cosine of y. Okay, so sine of x and cosine, everything is divided by the hypotenuse. So we're going to write hypotenuse all these points here, but we don't know what the value of our hypotenuse. Again, we're going to use Pythagorean theorem, right? We say this guy to the 2 plus this guy to the 2 is hypotenuse to the 2. So hypotenuse to the 2 is 1 to the 2 plus 2 to the 2. Okay, so 1 plus 4 gives us 5. That's hypotenuse to the 2. So hypotenuse is square root of 5. So I'm going to go ahead and write square root of 5 for the denominator of all of these guys. Okay? Now look at x. Sine, what we can see in front of it. 2. Okay, good. So this is 2. Well, we cannot see the other one, 1. Okay, so now look at this. Sine of y. What we can see in front, what can we see in front of y? It's 1. Cos of y, well, we cannot see the other guy, 2. So look at how sine of this is cos of that, and cos of this is sine of that. So there's a crisscross between the two. And this applies for all of the such x and y angles in all of the right angle triangles. Okay, that applies all the time. Whatever right angle triangle that you want to find in the world, right? Something like this, something like this, something like this. If this part is a 90 degree, let's pretend this is 90 degree and this is 90 degree. They're not perfect, but let's pretend like that. The x and y's, the other two, the sine and the cos are always swapped. All right. So that's it for today's tutorial. And if you guys have any questions, let me know in the comments below. And that's pretty much it. I hope you guys enjoyed it and stay tuned for other tutorials. Thank you. Have a good day.